I'm Anil Kumar, and here is one of the most important questions on trigonometric identities involving cofunction identities. The question here is to prove cosecant pi by 2 plus x divided by cosecant 2 pi minus x plus sine pi minus x divided by sine 3 pi by 2 minus x equals to 2 cotangent 3 pi by 2 plus x. Now, to prove this identity, I like to draw your attention to what we have learned so far relating cofunction identities. I actually remember it using two important aspects. The first one is the rule itself, in which quadrant which ratio is positive. So in quadrant 1, all are positive. In quadrant 2, sine is positive, here tan, and then cosine. So you remember this, all students take calculus or any other way. So first part is to understand where each one of them will be, and then we'll figure out what cofunction identity will it be. That is one part. Second thing which we need to understand is that if we are talking about, let us say, situation where it is pi by 2 plus x, then in that case we are talking about two triangles. Let us say first triangle, we say this is with the angle x. The other one is kind of pi by 2 plus x means that it will be like this. Do you see that? So in this case, the angle which we are talking about is this angle, which is pi by 2 plus x. What do you notice here? You notice that the base, let's say this is base, and that is opposite side. So what really happens is that this opposite side becomes equal to the base. Do you see that? And the base becomes the opposite side when we are talking about pi by 2 plus x. So in that situation, what happens is that cos becomes sine x, or vice versa. Tan x becomes cotangent x, or vice versa. Do you get my point, right? Of course, we have to combine these two informations. That is to say, when is each positive or negative. So we could have some positive negative terms here. So we'll figure out positive negative from the rule in which quadrant what is positive, and this kind of thing, if it is pi by 2 or something, opposite side becomes the base becomes opposite, resulting into that transformation. You get the idea. However, if we have a triangle which is kind of like this, same situation with an angle x, and if I do a transformation where this is kind of reflected here or there, whatever, these sides remain opposite sides. Do you see that? All are opposite. So basically, in these situations which involve pi or 2 pi, sine remains sine, right? So sine x will be sine x, cos x will be cos x, and tan x will be tan x, right? The ratio doesn't change. You get an idea, right? With this in mind, I'm going to prove this identity, right? So you don't really have to remember many things, but the concept which I've shown you here is one of the most important. So let's begin with the left side. So left side. First expression here is cosecant pi by 2 plus x. So cosecant will change to secant. So let me write down this as secant x. You get an idea, secant x. Now we'll check the sign. When I say cosecant, it means 1 over sine, so it relates with this. Pi by 2 plus x, we are in quadrant 2, where it is positive. So therefore, it will remain positive because the output of cosecant, which is 1 over sine, will be positive, divided by cosecant 2 pi minus x. Since it involves 2 pi, cosecant remains as cosecant. Sine 2 pi by 2 pi minus x means you are in this quadrant. Sine is negative here, so this becomes negative. You get an idea, right? Let's do it once again for the next expression. Sine pi minus x. Whenever pi is involved, sine remains sine. So it will be sine x. Pi minus x means you are again in quadrant 2. Sine is positive, so this is positive. I need not write positive. Sine 3 pi by 2 minus x. 3 pi by 2 means somewhere there, kind of like this. Do you see that? Okay, minus means of course it will be on this side. Okay, but sine becomes cos. So we'll write this as cos x. Since you are in quadrant 3, sine is negative, I'll write negative here. Does make sense to you? So go through this part clearly and see if you've understood, and then move on. So we have this kind of an expression. Now let's rewrite. Secant is 1 over cos, so I'll write this as secant is 1 over cos. Let me write this as 1 over cos x, and cosecant is 1 over sine, so I'll write 1 over sine x. And I could write this negative first here. Is it okay? Now here again we have negative sine x over cos x. Now that's what we get here also, sine x over cos x, right? So we have negative sine x over cos x, negative sine x over cos x, which is negative 2 sine x over cos x. Do you see that? So that becomes our left hand side. Now let's look into the right hand side. Okay, so on the right side we have 2 cot 3 pi by 2 plus x. 3 pi by 2 plus x means you are in quadrant 4, so this has to be cot is sine over tan is negative, this has to be negative. So I'll write this as 2 here. And since it is 3 pi by 2 plus something, cot changes to tan, so it becomes minus 2 tan x. And that's what we have here, which is minus 2 tan x. Do you see that? So minus 2 tan x is same as this, which is right side. So we have shown that left side is equals to right side. So that is how you should be doing a cofunction identity. It took me longer just because I was trying to explain you this concept, but otherwise kind of straightforward, but important to understand. I hope you understand and appreciate it. Feel free to write your comments on this set of videos. If you share and subscribe, that'll be even better. Thanks for watching.